Alright, so we're going to look at simplifying rational expressions, um, which involve multiplication and division. So first thing is, division is easy. We don't need to worry about division. You just multiply by the reciprocal. So this is the same thing as 79x over 25 times, use a dot for times, 27x to the second over 85. Oh wait, no, that's not quite right. If we're changing this to multiplication, we have to flip this fraction. 85 over 27 x to the second. Alright, so what are our common factors? Well, we have an x here and an x squared here. So x goes into x once, x goes into x squared, x times. What else can we do? 5 goes into 25 5 times, goes into 85, that's 10 for 50, so there's another 35 on top of that, so that's 7 and 10 is 17. And does 27 have any common factors with 79? Well, 27 is a product of a bunch of 3's, so just to test real fast, is 79 divisible by 3? I honestly don't think it is. It goes in here twice. That's 6. That's 1. Carry the 9 down. 19. 3 doesn't go into 19. So I don't believe there's any more simplification that can happen. So yeah, running this back for us, we change the problem to a multiplication problem. We simplify as much as possible, and now we just multiply through. Okay, we could have cross-canceled. All the cancellations are just where the common factors are. So 79 times 17, let's look for a calculator here, because I don't do calculations like that. 79 times 17 is 1343. Not a very flattering number. What is it again? 1343. 1343 over 5 times 27 x. So there's an x here. 5 times 25 would be 125, so there's 2 extra here. 5 times is 10, so it should be 135. And there are no... the only value this is not allowed to take on is 0, so x is not equal to 0, because when x is equal to 0, this fraction is undefined. Let's take a look at another example. Again, division is simple. We don't even worry about division. We're going to make this into multiplication, and we're going to flip this over. So this will become 12x minus 32, and this will become 14x to the fourth. Okay? I'm going to rewrite it over here just for the sake of being able to see it better. So yeah, it's 21x to the third over 30x to the eighth, y, oh, not y, I don't know where I'm saying y. Okay, 30x to the third minus 80x squared times, fix that, times 12x minus 32 over 14x to the fourth. Alright. And we'll clear that up so you can see the change. So these two problems are equivalent. We can do some cancellations, but when we're dealing with binomials and trinomials, it's best to factor before we do anything else. So these parts actually have factors. So let's factor. This is going to stay the same. 21x to the third. This denominator has a GCF of, I believe, of 80. There's a GCF of 10, 10x squared, so that's 10x squared, leaving over x minus 3x minus 8. The denominator here is going to stay the same, 14x to the fourth. And our numerator has a GCF of 4. Leaving over 3x minus 8. Alright, so let's see what we can simplify here. Obviously, 3x minus 8 goes into itself once, and it goes into 3x minus 8 once. Alright, what else is there? X squared goes into the x to the third x times, so that'll leave 1x over. One of these x's will go into the final x, leaving no x's in the numerator. What else can we do? 7 goes into 14 twice, and into 21 3 times. And 2 goes into 2 once, and into 4 twice. And I think we can do one last cancellation here. That is 2 goes into, bad color to use, so I'm trying to use blue. 2 goes into 10 5 times, and goes into 2 once. So leaving our numerator with 3 and 1, so our numerator is equal to 3. And our denominator remains with a 5 and an x, 3 x's, so 5x to the third. So what are the excluded values here? It's easiest to look at the excluded values in factored form. So before all this cancellations, we'd see that we can't plug in 0 into the denominator of either of these fractions, so x cannot be equal to 0. What else can it be? Well, if this expression is equal to 0, then this denominator is undefined. So the number that would make this undefined would be 8 over 3, because then we'd have 24 over 3, which is equal to 8. 8 minus 8 is 0. So if we plug in 8 thirds, this would be undefined. So also not allowed would be 8 over 3. So these two examples pretty much cover circling part of the answer, but not the whole answer. Alright, so these examples we've covered kind of cover the big picture here. If you want to simplify fractions, you need to factor. If you have a division problem, it becomes a multiplication problem. And your excluded values can be identified from factored form very easily. Maybe we can make up another example. So if we had 1 over 3x to the third plus 15x squared plus 18x, we'd be able to identify the excluded values after we factor this. I don't know why this is highlighted. I'm trying to unhighlight. Alright, there we go. Alright, so by factoring the denominator, it has a GCF of 3x. That would be x squared plus 5x plus 6. So, again, I don't know why that highlighted. Stop highlighting. I don't know why that changed pages. I apologize. I don't know why I can't get to the next page button. There we go. Alright. I guess I'll have to work with what we have here. Alright, so this denominator, currently we can't exactly tell what the excluded values are. This x, it tells us that 0 is an excluded value. But until we factor this, we can't see all the other ones. 1 over 3x. The factors of this trinomial are x plus 2 and x plus 3. X plus 3. So our excluded values here are 0, -2, and -3. So I hope this was informative, and I'll see you in class tomorrow.